Welcome to the Blue Security Podcast, a weekly podcast for information security defenders, where we bring you discussions on best practices, tools, and implementation for enterprise security. Now, here are your hosts for today's show, Andy Jha and Adam Brewer.
Welcome to the Blue Security Podcast. I'm Andy, your host.
And I'm Adam, your co-host.
Got a great show planned for you tonight. One of the things that happened last week, if you are on social media, is you know that Facebook and Instagram and WhatsApp all went down at the same time on one day. And Facebook published a after actions report, so to speak, of what happened and the effects of everything. And it's a really, really interesting read if you haven't read through it. We're going to post that link in the show notes for you. But when I read through this, I thought it would be a good topic to at least start the conversation with tonight, because there's a lot that information security defenders can learn from reading it and think about as you're trying to spin up different defenses and security layers for your company. So one of the things that struck me was, as you're reading through it, the reason why the network went down. And if you read through it, it talks about how there was a command that was sent to update the routing tables on the routers. And when that somehow updated, it, I think, erased the routing tables in the routers, and that was advertised over the BGP protocol. And once that happened, Facebook's DNS servers stopped talking to the BGP advertisements. And so the DNS servers weren't necessarily down, but because the BGP advertisements weren't there anymore, they didn't know where to go. And there's another security podcast that I listen to all the time called Security Now. It's headed by Leo Laporte and Steve Gibson, part of the Twit Network. A really good one. It gets into a lot more technical detail on last week's episode about BGP and DNS. And they really do a good job of explaining what BGP is. I'm not a network engineer. And even for me, when I listened to that episode, I learned a lot. So I'm not going to try to explain BGP to you. You know, I know what DNS is. I know what BGP is. But, you know, we're not going to explain that to you here tonight. But what I do think is important is, I think less and less people these days in information security are learning the advanced knowledge of networking. You know, basic networking is obviously very, very important. But as you're getting into like the deep knowledge of, you know, subnetting and BGP and all of that, I think less and less people know what it is. And I do think it's important to understand how that works. So, you know, maybe just a little nudge to learn a little bit more. If you don't know what BGP is and how the routing tables work and how BGP advertises, you know, maybe take some time and learn about that, because it's always good to expand your knowledge. At least that was for me when I listened to the podcast. I was like, man, this is great. I went and looked up a little bit more, read about it, and that's just kind of good. Information security defenders have that growth mindset and are always learning.
You know, recently the anniversary of Steve Jobs passing away, 10-year anniversary, came and went a couple weeks ago, and his collaborator Johnny Ive, who was Apple's chief design officer before he left the company, wrote a really nice piece remembering Steve. And one of the things he called out about him was that he had this insatiable curiosity, a curiosity of the world. And I think one of the ways, again, not saying you should all go out and attempt to emulate Steve Jobs, because I think our audience is a little different wired than he was. But one of the ways you can take one of the really good qualities of Steve and apply it to your, day-to-day lives are kind of going through the process Andy just described, where he said, hey, this event happened in the world with this major Facebook, WhatsApp, Instagram outage. And one of the things they talked about in their postmortem frequently was Border Gateway Protocol. And Andy, it sounds like you had a curiosity to say, gosh, you know what? I don't know a whole lot about BGP. I'm going to go learn about it. And that is something I think all of us can take a great lesson to learn and implement in our lives, is to take that insatiable curiosity. When you see something you don't know, take a minute right then and there while you have a real world application of it and learn it. And that's a takeaway I'm going to have from tonight's show. I'm still a little more ignorant about Border Gateway Protocol than I'd like to be. And that's something where, light reading, I'm going to pull up the Wikipedia article or something and educate myself a little bit, because I am curious. And this is so fundamental to how a lot of these hyperscale cloud services work.
So as I'm looking through the postmortem here, that was the first thing that struck me was, why it went down. And then they talked about the incident response. And because their DNS servers weren't working, they couldn't access the routers themselves. Literally, their entire network was down. And so typically, network engineers, when they're trying to access their network tools and their routers, they will have their in-band tool access, which is on the network. And then oftentimes they will have something called an out-of-band network access. And I dealt with this at my last position at my last company, where I was working with our network engineers who were standing up different networks at our newer offices that were on different continents. We had acquired some offices and some companies that were in Europe or in Asia, and we had to set up networks there. And most of the time, if there is a network issue, if your data center is right down the street or it's in the building, you can send a network engineer right to the network itself, the router itself, and physically access that router and troubleshoot it. You don't need network access. But when the router is sitting in Belgium or when it's in Japan, that's a little bit difficult if you don't have any network engineers on site that can do that. And of course, when the network is down, all work comes to a grind these days. So this network, out-of-band network access was really interesting to me because, again, I'm not a network engineer, so I never had to really set up these fallback situations and how to access it, and then really how to access it securely. If I have an out-of-band network access, I have to advertise that IP address to the internet. So how are you scoping that secondary ISP to maybe only be accessed by a specific set of credentials or coming from a specific IP address? Maybe it's scoped only from a jump box, something like that. But we had to design a solution that was secure because you're accessing something that is out of band and not on the internal network. So in this case, when you're reading through the postmortem, their primary and out-of-band network access were down. But that out-of-band struck me as really interesting because I ran across it in my previous organization. It's something that you may come across. And if you're not a network engineer and your network engineer talks to you and says, hey, I need to set up network out-of-band access, or maybe they already have it set up and they didn't think about security, that's something that you may want to talk to them about because this is not on the internal network. They may not have other security checks. So in this case, again, their primary and out-of-band was down, and then they had to send engineers on site. And then, of course, Facebook's data servers are very, very secure. So their physical access cards didn't work because they were on IoT devices and couldn't reach the servers. And once they got on site, even if they got physical access, the routers were configured in a way that didn't make it easy to modify. And those are all things that you want to think about, right? Like how easy is it to get to my physical routers, my physical servers? Have I configured it in a way that if I was on site, is there some sort of privileged escalation that you have to do before you can have access? So those were all things that obviously Facebook was doing really well because they're Facebook, right? And so they have a really good physical security as well as access security when you get to the servers. So I thought that was really important to kind of pull away and think about, how are you doing this at your company? And then finally, when they did actually get to the servers, they couldn't bring everything back up because as they were looking at it, they were flipping services back on. They realized that they could potentially crash again due to just the sheer amount of traffic that was coming in. And so these are called like storm drills, in the fact that like if there's a bunch of traffic coming in, that can overwhelm your network. And so they had actually practiced these storm drills in the event of a major system failure. And so once they got it to a healthy state where they can access the network, they just ran through their storm drills and they were able to bring up services in a manner that didn't overload their entire network. And I thought that was really important because we had talked about last week on having a plan and practicing that. And I realized that these Facebook engineers, they're doing drills. And so in the fact that there was a major service outage, it was an incident that they had to respond to. They didn't panic. They probably were panicking when they were trying to get into the physical building. But, once they got their network and everyone kind of could breathe a minute, they were like, okay, let's just run through our drills now, right? And so they were able to bring it back. So the entire post-mortem, really, really good read through, a lot of good takeaways for security defenders, even though it wasn't a security incident, so to speak. But I found it super interesting, and I just wanted to kind of give my thoughts on it tonight.
Working for a company, and both of us work for Microsoft, that has this hyperscale cloud environment, one of the things you realize as you hang out with engineers or product group folks and you start to hear some of the things that happen at these data centers, they don't always map one-to-one to a lot of our understanding of how you build infrastructure for like an enterprise, because they're so reliant on things like automation, where everything is automated to a level that would make most of us just heads explode. And so I wonder if part of these storm drills where they had to bring things back online in a very controlled manner was avoiding automation that would assume there was an incident and would take some sort of action to hand off traffic or to assume a data center was offline or a region was offline or whatever. That's kind of my suspicion, is part of why they had to bring it back on in a gradual manner, to ensure that I don't want you to fail over to that other data center. They're doing the same thing right now too. We all need to come back online in a smooth manner and just restore like fully operational service here and not try to trip any of that automation or something. But it's still really interesting to read through this. And I appreciate that Facebook walked everyone through this. And I thought it was really interesting too, talking about how secure their data centers were from a physical access perspective. Because when I think of Amazon and Google and Microsoft, they all host data for customers. So they're all cloud computing providers where in a Microsoft data center, it's not just Microsoft's data. They need to be good stewards of data for other companies who have entrusted them with it. But that is not Facebook's business model. Their data centers are just for Facebook. And yet they're still delivering this level of security and physical security and all of that. I thought that was really interesting too, when they have no other masters to serve other than their own, and they're still that focused on delivering it in such a secure manner. And I think I made the point several weeks ago that although Facebook and Amazon and Google sometimes have questionable privacy policies, their security really is top notch. And this spoke to it too. And it became a bit of a double-edged sword here, which was also interesting, thinking about the level of physical security at these data centers, and then the physical security controls were breaking because they didn't have internet connectivity. And so it sounds like they had a plan in place to deal with that, to do some sort of alternative identity verification. But those are all things we should be thinking about as far as when you have a full on everything's down failure, do you still have a backup plan in place to stay operational? And that's great food for thought as well. But what a great postmortem. It was a really compelling read. And I certainly don't envy the folks who had to respond to this, but ultimately this could have been a multi-day outage. So the fact that they actually brought this back up in hours is a long time and a lot of money lost for Facebook. The impact of this outage was a significant revenue hit for them, but make no mistake, this could have been a lot worse. I think ultimately they deserve praise. Not that I'm a big Facebook fan, but just from a technical perspective for actually the speed at which they brought this back up globally. It really is, I think, rather impressive.
Yeah, for sure. You talk about their backup plan. I had heard rumors that their backup plan involved cage cutters and literally cutting into the doors that were, securing all of their servers. They just couldn't get to them, so they literally had to cut them down. And they talked about how, they've never simulated a outage of their global backbone, but they're going to look at ways to simulate this in the future. So that's another thing. If you have an incident, no matter how big or small, document that and then run that into your drills in the future, right? Because if you see one, chances are you may see it again.
These hyperscale cloud providers too, they have so much fiber, private fiber, linking all their data centers together. And it's, they're really like an ecosystem in and of themselves. And so thinking about we'll never have a global backbone failure because we have our own backbone. We're not dependent on the public backbones. And, never say never, I guess, right?
Yep. So Windows 11 was released on October 5th. And there's been a lot of promotion around it. And one of the things that Microsoft has talked about are the security features. And I've heard and read a lot of articles, listened to a lot of reviews and people who are out there talking about it. And what I hear is it's really not any different from Windows 10. It's the same stuff. And to their point, some of it is the same. But tonight I just kind of wanted to talk about how Windows 11 is slightly different and actually more secure than Windows 10. So a lot of the security features, are all just part of this whole zero trust model where you're talking about from chip to cloud security, literally from the silicon to the endpoint, identity that access to sign into the machine as well as you're running the apps. There was a lot of criticism about the requirement of TPM 2.0. If you're not familiar with TPM it's the Trusted Platform Module, and it's either a separate chip or it's integrated onto the motherboard that helps protect, encryption keys, user credentials, other sensitive data that's left behind on the hardware barrier. It'll have logs from Secure Boot that may even be compared to other similar type machines in Intune. So there's a lot of integration of the security with the TPM. TPM 2.0, while a lot of it may not be very different from TPM 1.0, it is actually more secure. One of the things that, if you're going to talk about like TPM 1.2 versus TPM 2.0, is that 1.2 only uses the SHA-1 hashing algorithm. If you are familiar with the hashing algorithm, like SHA-1, we haven't actually used that since 2014. So a lot of agencies started moving to SHA-256, which TPM 2.0 supports and TPM 1.2 does not. And even Microsoft and Google, we removed support for SHA-1 based signing of certs back in 2017. And, the newer algorithms that are coming out, TPM 2.0 is the one that will support them. So it just offers a more consistent experience, a newer experience, and a more secure experience in general. So what I think Microsoft was trying to do is establish, kind of raise that security baseline, right? Just raise it to the point where we know. And that's kind of the whole idea of device security, is having a security baseline of, at least it's at this point, at least it's this secure, versus like backwards compatibility and having those lesser known, we always talk about having some exceptions, but this is where we're trying to raise that entire security baseline. And anyone who's on Windows 11, we know you're going to be at least TPM 2.0, right? And so I think, all those other features that use the TPM chip, like System Guard, Autopilot, Secure Boot, they're only available on TPM 2.0. Some of them, like BitLocker, you can use BitLocker with 1.2 for enterprises, and so it's not any more, quote unquote, more secure there. But again, there are other features of 2.0 that make it more secure. And then we're raising that baseline so that we know you're at least at this level of security. So I think that's a really important feature of Windows 11 that I just wanted to call out.
So I think one of the trying to think of how to word this. The double standards that people apply against Microsoft is they want Microsoft to be backward compatible with all of the things since the beginning of time, but they also want to hold Microsoft's feet to the fire on improving compatibility, or improving security, sorry. So keep compatibility, improve security. And those are two goals that are challenging to both meet at the same time. Now, Apple, who I'm a former Apple employee. I'm a big fan of Apple. I own a ton of Apple stuff. Love my iPhone 13, by the way. It's a beautiful camera. Great phone. Apple has this ruthless and absolutely ruthless ability to throw away compatibility in the name of security to move forward. Apple will do things like kernel extensions are no longer supported in Mac OS. And you'll have an entire ecosystem of stuff that uses kernel extensions. And they'll say, sorry, kernel extensions are bad. They're insecure. They're going away. 2 releases from now. Deal with it. Make a system extension. Done. And nobody even complains about it because they know, like, Apple's dead serious about it. They're going to move forward. And you can either stay caught up or you can whine about it. But either way, they're not changing their mind. And they are really, really good at security because of this. And one of the storylines I think has been lost and not given enough credit in the conversations of Windows 11 is that by establishing a higher security baseline moving forward, millions upon millions of PCs will ship in a more secure default state. And that is good for everyone. And I've heard the story of Microsoft's going to create all this e-waste because, all these PCs that can't run Windows 11. Windows 10 is not going away. Windows 10 is still supported until the year 2025. That's 4 years from now. So nobody is making you stop running Windows 10. Nobody is making your PC stop working. Nobody is forcing you to throw away your PC. It is good for another 4 years. Now, if your PC today already can't run Windows 10, which means it's 7th gen Intel Silicon, that means it's at least 3 or 4 years old already. By the time Windows 10 goes end of life, 4 years from now, that means your PC is 8 years old. I don't think that's unreasonable when a PC reaches 8 years old to say, hey, it might be time to move on. So I really, really, really want to emphasize that point. Windows 10 is still going to get updates, still going to get security updates, is still an incredibly secure version of Windows. All of these features that are in Windows 11, you can enable in Windows 10, by the way, too. And so continue to use it, keep it patched, keep it updated. You're fine with that. There's nothing wrong with that. If you have the ability and have the hardware to upgrade to Windows 11, It's a really good experience. It's really nice. But nobody is making you get rid of Windows 10. Not for a long time. And by the time PCs that are already incompatible with Windows 11 today reach end of life on Windows 10, they are very, very, very old devices that are probably ready for retirement anyway. So I just want to kind of set the record straight on that, because that's something that I think is misconstrued some of the time, and is, I think, also regressive in terms of delivering security progress. Security progress cannot always be delivered with zero pain or zero impact. And I think this plan to run 2 operating systems for the next 4+ years is the best possible way to deliver meaningful security improvements by default moving forward for all Windows 11 PCs that are sold today and going forward, while at the same time ensuring that the billions of devices on Windows 10 today are continue to be supported for many, many years to come. So I'll get off my soapbox, but I did want to clarify that one point as we go through this discussion tonight.
I think it's a really good point, because I don't think it's a situation where Microsoft has a win-win situation. You know, it's almost like a lose-lose situation, because as you step back and think about it, we're always criticized if we don't improve security, but then if we do something that tries to improve security and we make it worse experience or cause enterprises to have issues with it, then we're also criticized. You know, I remember even like when a few years ago, you know, Apple had already moved to the USB 3 and Thunderbolt, and the new Surface Pro came out and only had USB, A connections. And so, I think Microsoft makes a lot of those decisions based on how it's going to impact enterprises and legacy tools. And I think at this point, the people who decided were just like, we're just going to put our foot down on this particular thing, and we're going to just try to raise the bar for everybody. And like to your point, Windows 10 is not going away, so you can still run your system for 4 more years. And even those folks who are going from Windows 10 to 11, if you're doing a in-place upgrade, you're not going to just automatically enable all those security features, because these we've talked about some of these like CredGuard and System Guard, Secure Boot. Some of them can impact your environment, your experience. If you have Wi-Fi that's on an old protocol, they can impact some things when you're enabling them, which is why you want to test them. And so when you're just doing an in-place upgrade, those security features like virtualization-based security doesn't get enabled just because you upgraded to Windows 11. Now, if you do a fresh pave and complete re-image of the machine and you install Windows 11 from base, yes, all those features are going to get enabled automatically because that's the behavior of Windows 11. So, continue to use Windows 10, upgrade to Windows 11. You don't have to worry about some of these things just automatically enabling. But if you're getting a new machine, you're repaving to a new image of Windows 11, yeah, you're going to get some of this good stuff, virtualization-based, security, secure boot, UEFI. If you're still on the master boot record and legacy, boot, like you should get off of that. And Windows 11 is going to kind of force you to do that. Mm-hmm. So Microsoft published something back in 2019 called Secure Core PCs. And that was basically a recommendation of firmware, hardware, security settings to get to a more secure type PC, because Microsoft and folks in the information security world were seeing more and more firmware attacks. And so all of this stuff that is getting enabled in Windows 11 and then has been in Windows 10, as optional features, are things that are all recommended as part of that Secure Core PC. And so we're just kind of moving the bar and forcing everyone. And to Adam's point, like Apple does this stuff all the time. They'll get rid of stuff. They'll get rid of chargers within their phones, and packaging. They'll get rid of the headphone jack, and people will complain, but Apple doesn't ask for permission when they get rid of stuff. They just do it. And I think Microsoft, to their credit, they try to slow walk it so that they're not trying to affect people. But at some point, you know, in the name of security, and I think this is a good thing for everybody, we're just putting the foot down and saying, hey, this is the new baseline, and to get on it. The other thing you mentioned was the chipset requirement. There's been a lot of heartache about the chipset requirements as well. And, you know, virtualization-based security takes a toll on the system. And I think through some of the testing, even if your machine is capable of it, Microsoft has kind of tested and said, no, these are the chipsets that have the best performance when they're running these virtualization-based security features. So this is going to be the minimum. Not to say that you can't put Windows 11 on a machine that doesn't have that chipset, right? You can, but it's not going to be supported. So, you know, there's been a couple of posts out there where people have said, hey, you know, you can just get the ISO and install it on any machine. And yeah, that's true, but it's not going to be supported. It's not going to be recommended. Not to say that you're not going to get security patches, because I think, you know, you probably will, but legally, you know, the legal department of Microsoft is probably going to be like, well, we can't really say because it's unsupported. But, you know, in my opinion, you know, it's probably very unlikely that Microsoft would just cut off security patches. But again, because it's unsupported, we can't tell you, you know, that you're never going to not get security patches, right? So it's that fine line. But if you're following the chipset requirements, you're following the 2.0, the TPM 2.0, and you're all within the supported guidelines, you know, you're going to be at the best experience that Microsoft has dictated and the best security baselines that we have, right?
When I think of over time in the Office 365 service, occasionally web browsers are deprecated from support. For example, older versions of Internet Explorer over time have been removed from being supported browsers. That does not mean on that day a code push goes out to break support with that version of IE. It just means that moving forward, as new code is implemented in the service, it's not tested against it. Nobody's intentionally trying to break it. It's just saying nobody's validating it works. And that's the same thing here. You can install Windows 11 on unsupported chipsets, and patches will come down through Windows Update. Nobody tested them. Nobody promises they'll work. You're on your own. So when it said like they're not going to get updates, that was more saying they're not going to get supported updates. Nobody has validated it's going to work. If you are okay living in that world, knock yourself out. But you honestly might have a better experience staying supported on Windows 10. So, but yeah, I agree. And everything you said, just as far as sometimes you got to draw that line in the sand, because when you do that, that means that every PC that ships, you can walk into an Office Max or a Best Buy, and there's some really beautiful PCs in there, and there's some really cheap PCs in there. And even those cheap PCs now moving forward, they have this whole complement of security features enabled by default. That's amazing. That's huge, because outside of the enterprise, I'd be willing to bet none of that stuff ever got turned on outside of Surface. And now even the cheapest, crappiest PC at Office Max, that baby is still shipping with all that good stuff turned on. That's a win, guys. That's a win, gals, from improving our security game across the board. So I'm very enthusiastic about this. And again, I see no downside to this because everyone can continue to stay on Windows 10. So
the other really cool thing that I learned about, and it didn't strike me as important when the announcement came out back in November of 2020, but Microsoft had announced back then a new security chip, a new security CPU called the Pluton processor, and it was heralded as this new thing, and I didn't realize the importance of it. And so we had talked about just recently about the TPM design flaw, where that bus between the CPU and TPM can be sniffed, and information, specifically BitLocker keys, could be sniffed and used by attackers if they have physical access to your machine. Well, the Pluton processor essentially mitigates this design flaw by integrating the TPM processes into the CPU. And it's all within a secure core within that CPU and completely segregated, just like the virtualization-based security, where none of that information can get out of there. And so there's probably going to be multiple iterations of the Pluton processor, but right now when they come out, they're going to be kind of emulating the TPM the TPM specifications and APIs that are existing, so that it can still integrate with the services that currently use them. But what's important about the Pluton processor is that Windows 11 is compatible with the Pluton processor. And so, they haven't come out quite yet, I don't think, but they are probably going to be coming out fairly soon, since we have an operating system that can utilize them. And so the important part is that, if you're really into that security and you're worrying about not having to do a pre-boot pin, we talked about that TPM design flaw where you can sniff the BitLocker keys and all that. Well, now you have the security literally built on the chip. The TPM is integrated into the CPU, so there is no bus that you have to apply leads to and sniff that traffic. So I thought that was another win, right? So now we have security on the chip versus this design flaw that everyone's talking about. So we'll have no super secret nerdery that, people are hooking these leads up to the TPM bus and spending hours and sniffing those keys. So even if that were to happen, can't do it on the Pluton processor.
Yeah, this was a cool announcement. And one of the things that struck me, well, two things. Number one, it was called out that this announcement was made in concert with Intel, AMD, and Qualcomm. First off, it's just funny to see Qualcomm mentioned right alongside Intel and AMD, but that's where we are today, where those ARM chips from Qualcomm, those Snapdragon CPUs, are mentioned as well. And so all of these CPU manufacturers, designers, are going to build the Pluton capabilities into their CPUs or their systems on a chip. And so, like you said, Andy, that means they're either going to be on die or at least on package with the rest of this stuff, which is incredible and really does reduce the attack surface significantly. That's exciting that it's going to have API compatibility with TPM. That way, all of the existing API calls can be read and processed without any changes to software. And then moving forward, software can begin to adopt the additional capabilities of Pluton and get even more secure. So that's really cool. But did you know the genesis of where this whole Pluton project came from was from Xbox? And I always get tickled about how Xbox really adds an interesting dynamic to a lot of the activities of Microsoft. So as a security seller, one of the things I get to talk about is like Microsoft's breadth and depth of telemetry, how many threat intelligence signals Microsoft sees on a regular basis. And compared to a lot of security competitors that are enterprise only focused, they don't have visibility into the consumer space, or especially gaming is interesting because there tends to be a lot of intersectionality with hacker culture and gaming as well. And so Xbox Live, of course, gets attacked regularly, DDoS and other attacks. And the Xbox hardware itself is built in a way that assumes it's in a hostile environment. So there's kind of an old adage that if you have physical access, well, then you have access, right? And that's a way to dismiss like an attack like this TPM one we described a couple weeks ago, where, well, okay, if the laptop fell into the hands of the bad guys, eventually they can break into it. Like there's this shoulder shrug kind of thing, right? Xbox and game consoles in general are not built with that assumption. There are millions of them in the hands of people in their homes around the world. And the assumption is just because that Xbox sits in Andy's home or Adam's home all the time does not mean I can go easily break into it and make it run unsigned code or use it for other purposes. Like it is hardened in a way that it is still only going to run signed code and signed operating systems from Microsoft or from Sony or from Nintendo, based on your console. They're all designed with that same design assumption in mind. And so Pluton is taking that design ethos of I'm in a hostile environment and I should not be able to be broken just because somebody has physical access to it. And it's bringing that kind of back to the PC. And so I think that's really, really cool, is using those learnings from Xbox, which is essentially a PC running AMD Silicon, and then applying it to the entire PC industry. I like that backporting of ideas and applying it to the whole industry and making security better for everyone. I think that's just really cool. That's something that I just wanted to call out and share that story too, because that's part of kind of the genesis of Pluton, and where it came from is actually from the Xbox team.
The final thing that I'll mention that I think everyone should go and watch is this video, which we'll link to in our show notes, from the Microsoft Mechanics channel. And it talks about how Windows 11 is more secure. And the person who's hosting it is Jeremy Chapman, and he's joined by Dave Weston, who is our hacker-in-chief. He's the guy who started the Red Team at Microsoft. And what's really neat about this show is that he does some real-time hacking and runs, Shodan to find an RDP box that is exposed on the internet, and then it doesn't have any virtualization-based security, or it's running the master boot record and not secure boot, and he's able to brute force the password, all in real time using Kali Linux. And so this guy is, legit hacker who is running through the attacks that any normal attacker would do on some of these legacy systems that don't have the security enabled. He does direct memory access, and is able to pull and modify different reg keys for Windows Hello for Business. In one of the particular hacks, he uses a gummy bear to simulate a finger and fingerprint on the Windows Hello for Business biometrics keypad. And then he turns on virtualization-based security and realizes, okay, now I can't modify any of that information because all the sensitive keys have now been virtualized within its own container. So it's a really, really good video. It's not that long. It's like 17 minutes. Highly recommend that you go and watch it, because it demonstrates in real time when you have these security features enabled, this is how it mitigates the actual attacks that an attacker would run through, right? So I thought that was a really good one. I watched through it. I learned quite a bit, and realized that these are all good things that we should enable.
That's awesome. And he's a great follow on Twitter as well. If you don't already follow him, he's pretty great. So some good threads there.
So some good information this week. I thought it was a really great conversation. That's our show. And if you guys have any questions, certainly reach out to us on Twitter or LinkedIn. Our contact information will be in the show notes. Love to hear your feedback. If you have topics that you want us to talk about, or things that you're interested in having us speak on, reach out to us. Thanks, and we'll talk to you guys next week.
Thank you for listening to the Blue Security Podcast. Please check out the show notes, catch up on episodes you may have missed, and subscribe so you don't miss any future episodes. Find Andy on Twitter @AJaw0 and Adam @AJBrewer. See you at our next episode.